expert. For today's session, we will mostly focus on the optimization. But before we go on, discussing the optimization, we'll briefly discuss about who we are and what Cargill do. What are the different functions, businesses that Cargill is in, and then we will talk about the optimization, as in taking a use case scenario from the Cargill, and we'll talk about why do we need the optimization, and then we will, since you have been learning about the machine learnings, different algorithms, right? So we'll talk about where do you place the optimization in terms of the in the analytics space. Once we discuss, where do you place in the descriptive, prescriptive, or predictive, we'll talk about the basic framework of the optimization, and then we'll fit in the problem statement that we discussed within that framework. And then finally, we'll discuss about, what are the career opportunities that you can have in the optimization, and what are the basic resources that you can go through and learn more about the optimization. So moving on, my name is Mahendra. I'm senior data scientist here in Cargill, having 7+ years of experience in the operation research and machine learning. I did my graduation in chemical engineering from IIT Kharagpur, and previously I've also worked with Boston Consulting Group and one or two more organizations. So that's about me. I also have my colleague Soumya with me. I'll request Soumya to introduce herself.
Hi everyone, this is Soumya. I'm just a young professional. I just joined Cargill as a data scientist. As for my educational background, I have an electronics and communication degree from IIT Dhanbad and an MBA in business analytics from IIM Bangalore.
Thank you, Soumya. So now, since you know us, let us move on to what Cargill do, right? So now, if we talk about the Cargill is basically a food company, and it's not a usual food company where it only serves to the final customer and consumer, or let's say it only produces some of the intermediaries and serve those product to, let's say, the business to business, right? Cargill partners with food producer like the farmers, and then it also partners with the different, the businesses which produces the final product for the customers, as in B2B. And then we also have the presence in the financials and some of the other areas. If you talk about the strength, Cargill is more than 155,000 employees has worldwide, and we operate in 70 countries, but we do the business with more than 125 countries, with a 155 years of experience, spanning across different industries as well as geographies, right? Cargill did a revenue of, if you talk about 2022, 165 billion. So that's about the, brief introductions of overall what Cargill does worldwide and what are the employee strength. Now, when we look at the Cargill in India, Cargill started its operation in 1987, and currently we have almost 5,000 employees, and our headquarter is in the Gurgaon, and our technology application center is in Bangalore. We have almost 6 to 7 consumer brand in India, and you might have heard of those consumer brand like Gemini or Fresh, Naturata. And if you talk about the company revenue, we made 80+ crore last year. So that's about the overall brief of the Cargill in India. And now now we want to talk about, since you might not have heard of the Cargill or used any of the product of the Cargill on day-to-day basis, but this will give you a summary of, knowingly or unknowingly, where you might have used the Cargill product. So for example, when you wake up in the morning, first thing that you might do is do the toothpaste, right? So the sweet flavor in your toothpaste might have come from the Cargill. The second example, let's say you are fond of the chicken biryani. Now the chicken in your biryani might have come from the Cargill as well, right? And if you're fond of the chocolate, then the cocoa in your chocolate might have also come from the Cargill. So you see there are different examples of what are the product that Cargill produces, and without knowingly you are using the Cargill products. The other examples is that if you go to eat the burger in the McDonald's, the chicken or the oil that is used to prepare the burger also might have come from the Cargill, right? So Cargill has a diverse portfolio of the products which span across, uh, which serves to the final end consumer, or it also serves to the business to business. For example, here McDonald. Then we also have some of the biochemical products which are used as an input to produce some other finished good. So now we can easily say that since for this vast diverse product folio, and it involves across different uh, different, and it involves the different partners in the entire journey. Cargill is a farm to fork company, right? And to give you the overview where Cargill interact with the farm to fork in the journey of the farm to fork. So the first thing that Cargill do is the Cargill buys the crops from the farmer, and then in return, the Cargill also provide them the tools that is required for the farming, as well as some of the expertise like the weather data or financial help. Once Cargill buys those agriculture product from the farmer, either we store it and then do some value-added processing, or we transport those product across the globe to supply to the different countries. Then Cargill also procure the animal feed from the farmers, and then produces high protein products for the end customer, as well as for the customers like McDonald or KFC, right? And then once the Cargill does this processing as well as the value added product, either we serve these product to the customer via the retail stores, or we sell these intermediate product to the different businesses, which they again process and sell it to the final consumer. So you've seen that since from the farm to fork, to manage all of these things, Cargill has to build an integrated supply chain. Now, what do we provide in the integrated supply chain? If you talk about the supply chain for farmer, again, as we discussed, we buy from the farmer the agriculture product, and then provide them the expertise that is required. We also provide them the different, basically the partners, either it could be the farmers or the different businesses, or to the end customer, some of the data analytics and the risk management capabilities. And then we transform the raw material into the finished good. For example, when we buy the animal feed from the farmers, we process them into the high protein products, and then sell it to the either end consumer or different businesses. And then we move the product around the world using the different transportation mode like railroad or the ocean, right? So for such an vast and integrated supply chain, there are always or every day someone has to make certain decisions which would impact the flow of the materials, or how you transform the raw material into the finished good, or providing the different insight to the partners, right? So one of the use case that we want to take for today in the integrated supply chain is the optimization, where we'll discuss about the production planning and scheduling. Now, what happens is that in our protein manufacturing plant, we buy the animal feed from the farmer, like for chicken, and then for our beef products, as well as for some of the other products. Then once we buy these raw materials, we transform these raw material into something called work in progress products, which is like not the finished good that we can sell to the customer or to the other businesses, but that also requires some of the other processing to make it into the finished good. And then these WIPs or work in progress products are converted into the finished good, and then finally the finished goods are supplied to the end consumers, right? Now, when you transform these raw materials into the WIPs, there would be certain equipments or the processes that you would use, right? Or when you convert these WIPs into the finished good, you would use certain equipments and again the processes, right? For example, let's say the best example could be making the roti, right? Now, to make the bread or roti, you would buy the, let's say, the wheat first, then convert into the whip here could be the atta, right? And then finally you mix the atta, water, and cook it on a stove to make it into roti, which is called the finished good, right? So this is something that you can use to understand, the how Cargill convert the raw material, which is the animal feed, into the finished good, and what are the different processes that would be required in this process. For example, here you would require a uh, grinder to convert your wheat into the atta, and then finally you would require a stove, water, and the manpower to convert into the finished good, right? So and then you have the the different demands for each of these products that are coming in, as well as for, let's say, the demand is coming in for the next 7 days, but you have to plan for a the, let's say, the 1 year in horizon sitting today, to make sure that you have the enough raw material available to produce or to meet the after 1 month demand or after 2 month demands, right? So you also do the demand forecasting here, like what would be the my demand after 1 month or 2 month, right? Now, I wanted to discuss in this entire process of the production planning and scheduling, what are the complexities. So for example, here, what are the decisions that are made? So let's say in one plant, we are producing 100 products. Then someone has to go in and then decide which product we would produce today, and then how much quantity we would produce today, and then in what sequence we would produce today. So a simple example that you can take is, let's say you are producing 10 different types of the biscuits, right? Now, each different types of the biscuit has the different demand in the next 3 months or 1 month. Then they also, since these are different types of the biscuit, they also require different input raw materials. For example, in one type of the biscuits, you might be using jaggery instead of the sugar, right? In some other biscuits, you might be using different type of the flour instead of the wheat flour to produce those biscuits. So when you switch over from, let's say, the one biscuit to another biscuit, you need the different raw material as well as, let's say, the different equipments here, right? Because one type of the product might require mixing, heating, blending, and then cold processing. But other product might require just the blending, heating, and you can put it on a room temperature and it would blend. It would get into a solid space. So then you need to make sure that how much of each product I should produce today and tomorrow, and are those resources or the equipment are available while producing these products or not, because these different products use some of the equipments as the common equipments, and some of the unique equipment which are not required for other products. And then also, once you switch over from, let's say, the one biscuit to another biscuits, you have to clean the equipment. So you have to take the changeover, which is called the, let's say, the transition here. So some time would be lost in cleaning those equipments, and hence you would lose some of the let's say, the throughput or the production. So you see here that there is so much variability here, right? There are hundreds of the different product that you have to plan and schedule. Then each product can be produced using different equipments, as well as using the different mix of the raw materials, right? And finally, you have to make sure that these products goes into the quality inspections, and the quality inspections require different times for these different products. And with all of this, you will also have to ensure that you are minimizing the cost that will incur while producing these products, right? So there are hundreds of the variabilities, and one person sitting who is doing these production planning and scheduling can't handle, or it's not possible to handle such combinations of the different things to make sure that the it's produced at the minimum cost, as well as all the demand and supply is met, right? Now, so here you have seen that why now we need the optimization, right? Because there are difficult decisions that we have to make, and these decisions are so many decisions, we don't know which one to choose, because if you talk about the permutation combinations of the different these decisions, these becomes a large set of decisions, right? Now, it could be, let's say, if you're working on a corporate, and you have, you know, you have built up inventory of the different products, let's say the biscuit, the 10 types of the different biscuits, you are not able to sell, and hence the inventory is built up now. And your boss says that, hey, what do we do to this inventory? You might say that, hey, let's sell it to the customer. But would that work? No, right? We are here, those products, to sell it to the customer, but we are not able to sell, and hence the inventory is there, right? So, so your boss tells, okay, what could be the solution here? And then you say that we don't have anything, because you don't know the optimization right now. And your boss might say into the boardroom and say that, hey, let's sell it to the customer. But again, then that would not work, and it would be a really embarrassment for your boss as well as for you. So since, because of these difficult decisions, we need the optimization, right? And it could be not only these difficult decisions, there could be other scenarios as well. For example, there are so many options to select. For example, if you talk about the e-commerce, how they deliver the product from the supplier to you, they have different. So for example, you have placed the order for, let's say, one sweater. Now they can supply that sweater from the seller to you using the different routes. Now, which route to follow is something, because everyone is placing the order, right? And every order can be placed to the different sellers, as well as there are different customers sitting in different parts of the India. So it becomes too many options, like which options to select for each customer as well as for each supplier, and hence we need the optimization, right? Now, sometimes it could be the case that it's very hard to evaluate. For example, if you talk about the chemistry, where there are reactions happening, and these reactions changes the output based on the temperature and the pressure, right? So now, what are the combinations that you take to maximize, let's say, your revenue or the product? Then it will become hard to evaluate, okay, what are the temperature, pressure that we should use, as well as the chemistry that it should follow, right? So there we would again require the optimization. Sometimes it could be the case that you are unaware of the situations where you have to make the decisions. For example, if you are working in a refinery where the crude comes in and it gets splitted into the different products like petrol, diesel, naphtha, right? Now, how much petrol, diesel, and naphtha that you get from the crude varies based on the properties of the crude, the pressure, temperature of the reactor, and then distillation column, right? Given all of these complexities, and the person who is monitoring the entire, the process might not be sure that, hey, the crude has changed, so now I have to change the pressure and temperature profile, let's say, right? So there we would again need the optimization to make sure that we are operating based on the market conditions and maximizing the or company revenue, or as well as the bonus that you will receive. The other example could be where you might need the optimization is, let's say, if you're making certain investment, and there, people would have biases towards certain investment. So how to select a portfolio where you would maximize your return and not have biases towards, certain investment. So there the algorithm won't be the bias, and you can achieve, you can achieve the maximum return based on your portfolio as well as the investment. Now, given that we have understood, in what are the scenarios that we would need the optimization, as well as what are the complexities that are there while, working in optimization problem. Now, and you have also been learning about the data science, the different, the predictions algorithm, let's say the classifications, clustering, demand forecasting, right? So now, where do we place the optimization in the analytics space? And you might have heard of these four different types of the analytics, like the descriptive, diagnostic, and predictive, and the prescriptive, right? Now, if you talk about the descriptive, you get the answer that, okay, what happened, right? For example, you have 10 retail store where you are selling the groceries, right? Through the descriptive, you will get to know how much sales did I make, what's my revenue, what's my profit or loss. right? And your focus would be on the input that is used to derive all of these things, right? And you will have the complete business context here, and you will get the answer on what happened. Now, when you talk about the diagnostic, here you will again focus on why did it happen, right? Like, let's say your sales dropped, then you would try to find out, why did sales drop? Is it because of another store came up? Is it because of some festival or the vacations, but your stores are in the city where everyone goes on leave? Or why, what's the case where your sales has dropped, right? The predictive will tell you what would happen next in the future. For example, you have again the 10 stores, right? Where you will need to plan that each product should be there in your product available for the customer to buy. So you will also have to plan such a way that you don't end up with so much inventory in your stores, as well as those products should be available, right? So how much to buy and what would be demand in next, let's say 1 month or 2 months, would the predictive analytics would tell us that. The next comes the prescriptive, where it would tell, based on all of these business contexts, the input data, what you should do. For example, once you have the forecasted demand, how much to buy, when to buy is something that the prescriptive will tell you. So this is where we put the optimization, because optimization tells us what are the decisions that we need to take, right? And so always the focus is on the results or what we need to do. Now, since we know now where do we put the optimization in the analytics space, and you might know this definition of the optimization, or we can derive that optimization is the way or the process to find what are the right decision given the business that we know, as well as what we are trying to achieve. For example, for certain businesses, you might say that, hey, I want to maximize the revenue. But certain businesses, you might say that I want to minimize the cost, right? And there you could also model something like you want to maximize the total productions or minimize again, the transportation cost or something else. So it's a way to find what are the right decisions given the business situations as well as the objective, right? Now, we said that once we know about the why do we need the optimization, where do we place in the analytics space, we will talk about the basic framework. Like for the predictive analytics, you know that once you have the input data, you will decide, okay, which type of the analytics that I should use, like the clustering, supervised learning, unsupervised learning, or the demand forecasting, right? And then you will select the features, apply the algorithm, check what is the accuracy of that algorithm, like let's say the mean absolute error or mean absolute percentage error, and then finally select whichever is the best given the business context, right? Here, similar to that basic framework, we will say the optimization follows the three things. One is what are the decisions that we are taking, right? The second, what we are trying to achieve, which becomes the objective functions for our problem. Then third thing comes the constraint. The constraints are basically what are the resources that are available to you, which you can consume, and only by consuming those resources you can achieve the objective that you are trying to achieve, right? So this is a basic framework of an optimization. In some cases it might varies, and if you read about the optimization, there are different types of the optimization. Again, the linear programming, the mixed integer programming, then non-linear optimization, right? So we will not go into those details, but here we'll talk about the basic framework, and then how do we put in the business problem of the production planning and scheduling into this basic framework. Now, in the planning and scheduling framework that we discussed, we what are the decisions that we are making here, right? Because we said that when a person comes in, he has to plan which product to produce and how much to produce. So that becomes a decision variable for us, right? The second decision variable becomes, we took an example like, the switching from product A to product B, why does that matter? So the second decision that he has to take is that how do I make sure that my changeover time is minimum? Because when you're cleaning up your equipments, you will lose some time and hence the production, right? So those are certain decisions that he has to make. and hence these become the decision variable for our optimization model. Now, when we talk about the objective, in this case for us, the objective had the multiple components. The one objective is that we want to meet the demand, but in case we can't produce and meet all the demand, then we want to minimize, how much demand we are missing. The second thing that we want to minimize is that we can also use the plant for the overtime. So we can pay the customer we can pay our employees overtime and then use some of the overtime to produce the products. But we want to minimize that as well and use the regular timing to fulfill the demand. Then the other objective component becomes we want to minimize the transition time so that our total production quantity is maximum, right? And then we also want to maintain safety stock for each product, as well as we don't also want to maintain so much of inventory, because else we will end up with higher inventory cost and our capital would be stuck there. So all of these component becomes the objective functions for us in this problem. Now, the third thing in the basic framework was what are the constraints, right? Now, when we talk about the constraints here, the availability of the raw materials becomes one of the constraints. Then you are using the resources or the equipments to produce these product from the raw material to finished good, and then raw material to work in progress, which is called the intermediate products, and then to the finished good. So you need to make sure that these resources are available. So these becomes one of the constraint for us, right? Then you have to meet the, let's say, the safety stock requirement that, hey, I want to maintain at least 100 quantity of each of the product or 200 quantity based on, what's the demand in your future horizon. Then there could be, certain process specific constraint, which something like, let's say if you are producing product A, then you can't just produce one unit. Let's say, you are producing Parle-G biscuit. You just can't produce 10 units, but you will at least have to produce 100 units so that the cost is minimum and all those things. So the minimum batch size requirement comes into the constraints, right? Then you might have, certain constraints which are specific to, let's say, your employees are available on or work in certain shifts. There are certain employees which they have the certain expertise and they only work during the day shift. So now the materials that require the specialized skills cannot be produced during, let's say, the night shift or the afternoon shift, right? So you need to also make sure that you plan and schedule those material during that shift only. So these are some of the constraints that are there for us in the planning and scheduling model. And to solve this entire problem, we use the Python to model the entire constraints variable as well as the objective function. And then we use the Groby solver to solve the problem to get the results. But if you look at the market, there are different software as well as the modeling language that are available. For example, the LlamaSoft is one, which also had its own solver. Then you have the AIMS, which can be used to model the problem and then can be used with the Groby Cplex or the open solver, which is the CoinOR. You can use the Python, Java, or even the Excel. You can do some bit of the optimization by using the Excel inbuilt solver or by incorporating the open solver in the Excel, right? So these are some of the tools that are available in the market. Some require cost, right? They have to be procured as in license. Some of them are available as in free of cost. For example, the open solver and coin open solver, which is by the CoinOR, is the free of cost, which you can go and download and then use it. On the left hand side, you can use the Python or with the Excel, right? So these are some of the tools that you can use to solve an optimization model. Now we'll talk about what are the different scopes and skills that is required to succeed in this space. And for this, I'll hand over to my colleague Soumya. Soumya, over to you.
Thank you, Sandeep.
Yeah, everything is fine.
Yeah. I hope I am visible and audible. So I'm going to talk a little bit about the career options that are present in the data science space and the kind of skills which are required and the kind of courses that you guys can go through to build your skills accordingly. Now, before understanding what kind of skills and courses that you guys need to do, you need to understand what kind of problem statements or the kind of scope which is there in data science industries right now, so that you can align your interest according to what is out there in the industries that it has to offer. Now, first of all, we already talked a lot about the applications of data science in the supply chain space, the biggest one being the optimization. Other than optimization, there are other fields that you guys can explore, and the use cases are a lot, like demand analytics, replenishment planning analytics, transportation and analytics, and all. Now, moving on, if you take the banking and the financial services space, here the use cases varies from fraud detection to risk modeling to credit underwriting and credit scoring. Now, here, as you can see, like small BFSI firms where you go to apply for loans, there they have their own ML engines, which can actually give a credit score and then decide whether you can get a specific loan or a credit card or not. This is one of the very popular use cases and very interesting one as well. Now, in the media and entertainment space, mostly it is about customer sentiment analysis or the targeted ads that you guys get nowadays in almost all of these social media platforms. Whatever you are scrolling or browsing through, you get exactly that as an offer from probably Amazon or other shopping sites as well. So this is something media and entertainment is using a lot for their selling. Now, moving on to the healthcare space, here the major use case is on the diagnosis of diseases. For example, the identification of a cancerous tumor using computer vision and ML algorithms. This is one of the biggest space out there. Other than that, there is some post-care monitoring and hospital operations as well, which are there in the healthcare space. Now, moving on to the retail space, here, one of the biggest use cases is intelligent cross-selling and upselling. So the kind of bundles that you guys can see when you order a particular product on Amazon or Myntra, those bundles are actually created by intelligent ML algorithms where they kind of group the similar kind of products together so that it is best for the user experience and best for in their selling point of view as well. Now, moving on. Yeah. Now, when you understand these are the kind of opportunities which are out there in the data science space, you need to understand what kind of job opportunities are out there or what kind of roles exactly are there in the space. Now, the most famous ones which are out there is being a data scientist or data analyst or business intelligence developer or a business analyst as well. Now, for all these roles, there is a very slight difference. Now, it completely depends on the kind of industry that you're going to work for, the kind of company, or the projects that your particular team is working on, and the skills required or the tools required might be completely different. But we have kind of tried to list the important ones out here so that we can, you can understand the difference between each and every role out there. Now, if you see on the right-hand side, you can see that programming is something that is required majorly in the data science space, and you need to have a command on a particular language out there so that you can understand the space better. Now, other than that, skills like visualization, statistics, machine learning, these kind of vary according to the role that you're going to work for. Now, we have tried to list down the most essential skills which will help you go a long way. Now, for the technical skills, statistics and mathematics, and I'll add the programming languages as well. Now, these actually help you a lot in understanding any kind of data science problem, or you're trying to formulate a data science problem in a particular language. Now, soft skills like collaboration or critical thinking, problem solving, this is something which is required in any kind of corporate career, I would say. Now, other than that, skills like documentations, economics, and analysis, this can be job specific or industry specific that you guys are targeting for. Now, We have tried to give you a typical day-to-day responsibility for a person working in the data science field. Now we'll try to relate it with the particular product life cycle chronology sort of thing. Well, first of all, you need to understand what kind of business challenges and value proposition your particular product or the kind of problem statement you're trying to solve with a product is. Now, first of all, when you understand that this is the problem statement and this is the kind of pain points my particular model or particular product is going to solve, then only you'll be able to, match it with the correct ML concept and then go for the development further down the line. The next thing that comes into place is understanding data with the help of business experts. So in our space, it's actually very rare where you get the data in a nice Excel or a CSV file. It's almost never that way. You have to do a lot of data wrangling and other data processes to get the data properly and understand what your data is doing in the first place with the help of business experts so that you do not make use of data which is actually not required for the particular problem statement. So this is something that we do almost on a daily basis where we understand what data is required for a particular problem statement. Now, next being model results interpretation and value confirmation. So once you have a model or a product in place, whatever you give into the model, it's obviously going to give an output. Now, to make the business users or the end users understand that your model results are actually helpful and it's interpretable. So as you can see, a lot of models out there are still in the process of being interpretable. Like deep learning models and all are still in the phase where it's a black box and you cannot actually, make sense completely out of it. So once you have the model in place, you have the results in place, you need to understand and make people understand what your model is exactly doing to give this kind of results so that they trust your model and trust your results for the end users. Now, next, investigating optimizers solve quality related challenges. Now, this comes for any kind of ML algorithms out there. So once you have everything in place and your model is running and giving good outputs and people are using it, we have to come back to it time and time again to understand whether my optimizer is giving the kind of results that we want in the long run or not, or do we have to do some tweaking again, change some parameters again, or go back to developing something, a new feature as well, which is the last point there, where building new features and deployment to production is again we do on a daily basis, where we understand the new use cases that we need to add or new features that we need to add according to the end users. Now, yeah, lastly, we have tried to mention some kind of learning materials that are present out there for you guys to understand optimization a little bit better. Some of the courses are from your faculty as well. You guys can go to NPTEL or YouTube where you can go through these courses. Some of these we have also went through and it's really good. You can understand optimization very good over there. Now we have tried to include some optimization models and examples as well, where you can go and do a hands-on training where it's I think is in Excel. So you'll understand Gurobi Optimizer also a bit better, and you can develop your own models from there. So that is all we have from our side, and we are open for questions now. Thank you.
Okay. So we'll see, what are the information that we can share and what are the not. Mostly we should be fine. Anything specific to Cargill, we'll remove those and then we'll share the required information that you need to your organizer, and then they will share with all of you. What was the second question on the chat?
I think that's
okay. Let us know if you have any other questions for us.
Can you please show the previous screen?
Yes. This one?
The one with the courses list. Okay.
Ma'am, can you please post the link in the chat box?
Yeah, we'll do that just after the, we'll also share the PPT with the organizer and they can share it with you. But for now, once this call end or before the call end, we'll just paste all of these, the learning material as well as the examples on the chat.
Okay, and I just have one more query, that is DSA, any kind of DSA required for the Python part?
When you say DSA, can you?
I mean sorry, I mean the data structure algorithms.
So for the
Really?
optimize,
देख ले भाई दिमाग।
sorry.
ऐसे जुगाड़ है भाई।
Okay. So for this optimization role, we do not require specifically data structure or some of those algorithms, but those does come handy because you need data in certain formats to build the input as well as the output uh, for your optimization model, and hence what's the best structure that you have so that it doesn't consume so much of memory as well as the processing power. That's where the structure algorithm comes in handy.
Okay, sir. Sir, one more question. Is there any kind of internship or opportunity in Cargill? If you can share something about this.
So we don't offer those kind of the opportunities over the call, but if there are any, we will come through your campus hiring placement team, and then they will inform you.
Okay, sir. Thank you.
One question. Can you hear me?
Yeah.
First of all, thanks for sharing your expertise in the field. I appreciate that. Um, you know, in the field of optimization itself, let's say in retail or the supply chain optimization, what you discussed, what we discussed. What do you think? I mean, how ML is affecting this particular domain, optimization domain specifically? And maybe if you have any examples related to supply chain or retail, that will be interesting to hear.
Yeah. So I'll take a classic, our use case example only, where we are doing the production planning and scheduling and how we are uh, operating with the machine learning, right? So I said in one of our slide that for the optimization model give you what are the decisions that you have to take, right? And the decision that we are taking through the optimization model were when to plan, how much to plan. But to get to know how much to plan, when to plan, you also need to know what is your demand in the next 1 month, 2 month, or 3 month, let's say, right? Now, how do you get what's your future demand? That you get through one of the machine learning models, let's say here the time series model, right? So for the time series, we have a different team, and the session will come up in, I think, the next week, where they will explain how we are using the machine learning models to forecast for the future. And these forecasted number comes as an input for our optimization model, right? So the success of the optimization model depends on how accurate your forecasts are, right? So that's where we are interacting with the ML algorithms and using those. There are
Right.
different use cases as well, but in this particular use case, that's where we are using it.
So first of all, probably you are using some historical sales data or the time series data to predict or to forecast the demand, right? The future demand, and then you are using this inventory optimization or any, let's say, price optimization part to optimize those part. Is my understanding correct? My question is more related to this particular optimization field itself. I was going through some papers, where I was curious to understand that in optimization code itself, how some of the decision parameters um, can be can be used. Let's say there are hundreds of decision variables available in your optimization problem. Uh, how ML can be utilized over there to extract some of the most useful decision variables, right? So that you can make your optimization engine more efficient. So I'm just curious to know from your side, like if you guys have worked on such domains, such topic, And if you can share some words on this, that will be great.
Yeah.
So,
Yeah. So I'll give you an example where the ML model is directly used in conjunctions with the optimization model, right? Uh, so okay, if you know about something about the steel industry, what happens is that the how the steel is produced. I won't go into the details, but there we were building a process optimization model where we were trying to optimize what are the parameters that you set to get the maximum output. Okay. Now the relationship between the output and the input variable is not defined, something that you cannot write through the equations. Okay, it's a variable. And to define that equations, we use the machine learning model. We started with the linear regression model, and then we used some of the non-linear model like the tree-based, right? And then we use these models like so it's a slightly different. It becomes very complex when you try to use the ML model within the optimization model. Okay,
mhm,
so we found a way to convert those optimization model object into equations, right? And then those equations were fed into as a constraint in the optimization model. So again, here it the accuracy of our optimization model highly depends on how accurate our predictions model is, which is basically derive the chemistry between the input and output variable. Because that chemistry is something that is not, you not available theoretically, and hence we had to derive using the input data and using the ML algorithm.
mhm,
But it becomes quite complex to use the ML algorithm within the optimization model, because then it becomes the nonlinear model, and then how do you solve the nonlinear model? Again, those things comes up. So, these are not separate areas, but these two interact with each other more often than what we think.
mhm. Okay.
Uh, did I answer your
Just
question?
last, yeah, definitely. Just last question. I think you have shared like what all tools you are using, but I mean, you shared a wide range of modeling tools and solver tools what you guys are using.
Mhm.
I mean, what's generally there in the market, but what specific tools you are using as in your organization? Just wanted to know.
So we are using Python with Groby, as well as so with the Cargill. If you talk about the different businesses, we also use the Python, AIMS, Groby, and Cplex. These four tools. Okay. But if you learn, any of these, the basic of the optimization and how it works, how you can formulate the problem, I think you would be good with any of the tools that are available, because then there are certain syntaxes that changes with the tools, and it's not a problem because you can get those syntaxes from the Google, right? So I would say focus on the basic of the algorithm, and then pick anything like for you, you can use maybe the Python that would also help you with your ML part, and then use the open solver to make it a complete package.
Thank you. Thanks a lot.
Hi, I have a question. It's more about a career path. So I just started out my career path in data science and I'm taking this degree. I just want to know if you have any inputs on any tips, what should I choose or what things I should avoid and do in my career to like get a job in data science further out.
Yeah, that's a very specific, like what to do and what not to do. It might come to the, what are the interest that we have, and then follow, what are your skills and what you want to learn and what's your career path that you want to achieve. But I'd say, if you talk about the ML path, right? You learn about how the algorithm works, how to use those algorithms, how do you think of a business problem and then solve using those algorithms is something which is very critical, right? And then once you see that where your interest lies, maybe uh, use it with some of the examples that are available in the open source, try it out, and then see how it works.
Right.
But yeah,
So I've been trying to, solve HackerRank and these lead code problems. And I was just wondering how much does that actually help when I go for a job, like in a real scenario, how much does that help, or should I focus my energy on different things that would you personally give more weightage towards?
So I would say, those experience of solving the problem does come handy, very handy. Okay. So that while interviewing, you can give the example that, hey, this was the problem. This is how I solved it. And I would say, don't just focus on how you solved it, but also try to understand, okay, what's the problem and why do we need to solve this problem? What's the value that it would add, right? So try to completely understand from end to end, like, understanding the problem, the impact of this problem once you solve it using the analytics, right? Why we are using the analytics on top of that problem, and what are the methods that we are using. And when you select certain methods, why did you select just that method and not, the other method? So having that complete knowledge does come very handy and helps you when you are interviewing for the different job roles.
Just a very simple question, last one. Other than getting a degree or, other certifications and all these hacker ranks and internships, is there anything else that you would suggest doing that would put me against the crowd or us against the crowd, that you have seen in the past or something?
Yeah, so see, these are the, the good tools as well as the area to learn and expertise yourself. Then when you go for the jobs with the, let's say the 10 candidate, 20 candidate, when you're competing for the one role, the things that might come out is your communications, your critical thinking, right? Those certain soft skills which the organization look for, like, how quickly you can understand, even if you, let's say, you don't know one business, right? How quickly you can learn and then apply the knowledge that you have, right? So some of those areas where how you think as well as solve the problem is something that will come handy, and then your communication skills, those things. But I think, if you solve the hacker rank problems as well as cover the basics of the ML, you would hit a good ground.
Thank you so much.
Hello, sir.
Yeah, please go ahead.
Yeah, I have a doubt in that.
Sorry, I couldn't hear your voice.
So, am I audible, sir?
Yes, now it's clear.
Yes, sir. I have a doubt in that learning materials you are sharing.
Okay.
Yeah, I think you are sharing for this optimization topic, you are sharing this
Correct.
foundation mathematics like linear programming and operation. So, I want to know about like these two are enough for this optimization, or we need to build like the topic of something else other than this in mathematics oriented.
So once you go through this, you'll get the basic understanding. And for the starter, I think that would be a good place to, start. And then slowly, once you start on your job, obviously, the learning doesn't stop. So you can learn as much as you want with your peers, as well as, there are trainings with each organizations. So I would say these are the basics that are, something that you want to learn, and then uh, continue your journey of learning along with your job.
Okay, thank you.
So any other questions if you have, otherwise we are almost on the time. So okay, I'm not sure if I missed any of the questions on the chat. So if I did, please feel free to raise your hand and then let us know.
Hello,
Thank you.
sir.
Yep.
Sorry to. Just the last question. See, I've done ML project as part of this course. My query is that, uh, is it enough to start with just understanding the ML algorithms better, or do we need to involve deep into deep learning to understand from a industry point of view? Like, from industrial point of view, do we indulge deep into deep learning, or the basic? It is okay to start with the basic machine learning algorithms. I mean, deep understanding of the machine learning algorithms is just enough to start with. So, just want to understand that part, sir. From career point of view, you can take it like, if you're good enough to work with the ML algorithms, it is good to start, or do we need to have more deep knowledge, like understanding the um, deep learning areas as well? So that is the question.
Yeah, sure. I'll take that question. So first of all, what you need to know is the basics of normal machine learning algorithms that are being used out there in the industry. Now,
Okay.
learning the basics is always there, but other than that, try to identify the use cases which are being used. So if you go for any interview in particular, any industry or anything, so that you can show your projects as an example to make them understand that you know the particular industry or the particular project. So rather than going deep into the mathematics, I would say, so it completely depends on the kind of career path that you are trying to choose. If you want to go more into the research field, then yes, you should pick a field where you need to understand the complete mathematics and all. But if you're trying to lean on to something more to the corporate side, where there you need to understand the use cases. And I would say that deep learning is still not much out there. So you need to have a hold on the simple algorithms that are out there, and then understand the use cases which are being used in the industry. That would help you.
So we should be specific in the domain where we are entering. Am I right? The algorithms which could help for that particular domain.
No,
Am I right?
so yeah, in a way, yes, where you need to understand what kind of domain that you're going to work for. If you have that, in your mind, then you can go ahead and try to understand the applications of algorithms out there and then do it. But then again, basics of ML is something that you need to know always. So again, if you have some domain or some industry that you really want to work for, you can completely explore that in depth. But then again, you need to have a basic understanding of ML algorithms, even deep learning algorithms, basic understanding you should have.
Okay. Okay, sure. So, I mean, from industry point of view, do they expect understanding of basic libraries, or do they expect like a TensorFlow, that, I mean, the advanced libraries like TensorFlow, that kind of a thing?
Yeah, that would highly depend, highly depend
Yeah.
on the role, I would say. Some of the companies that you might be interviewing might ask you that, hey, what's the TensorFlow? How does it work? Those things, right? But some might
Okay.
not. But I'll say, the learning never stops, right? And it's never enough. So if
Okay.
you can learn, that's good. If you don't, then basic is something that you want to cover the first, right? And not have that, hey, do I first learn the deep learning and then go for basics? No. The answer is always focus on the basics first. And then if you have the time as well as the energy, interest, then go for
Yeah.
the
Okay. Thank you, sir.
okay.
Thank you so much. Yeah. Thank you both.
Thank you everyone for joining this call. Hope we, had something interesting for you guys and you are taking something back. So thank you for joining. Yeah, bye bye.